Hello, your little mathematicians. Welcome to lesson 7.01 about positive and negative numbers. Some of this stuff is going to be a little bit of review, but we're going to be talking about how we use positive and negative numbers, especially in a context or situation. But before we get to that, let's talk about how your lesson is going to be working today. Today, your class is synchronous and asynchronous at the same time. What that means is I want you to pull up this Edpuzzle video that hopefully you already have open right now because you're watching this video. And I also want you to go to student.desmos.com and open the lesson with the same name. That means if I were to draw kind of an example of what you will be doing today on your computer screen, you're going to have your computer screen right here. You're going to have your Edpuzzle over here, and you're going to have your Desmos over here. That way you can be listening and watching, and you can also be writing. So it's just like if you were in the class with Mrs. Condrick or Mr. Rag. You're doing the Desmos as your teacher is talking. You're not just doing one or the other. So again, these should be done at the same time. You will only get credit if you do both, again, at the same time. Don't do one and then the other. You can always pause the video if you need to do part of the Desmos slide. You don't have to be expected to do it stroke for stroke with Mrs. Condrick. So again, do not use just the Desmos. The Edpuzzle is the same as having your teacher in the classroom at the same time. Before we start with today's lesson, let's do a little recap about Wednesday. So Wednesday, you were looking at how two quantities related to each other. In this case, our x and our y. We call x our independent variable, and we call y our dependent variable. What this means is if I put in a number for x, something is going to happen in order to get the value of y. We've talked about it as a function machine. If I put in a value of x, it goes through a function machine and it gives me, so something math happens and that equals my y value. So in this case, we can write x in terms, or y, what is the value of y in terms of what is happening to x. So we want to know what is happening to x in order to get to y. So how would we get from 3 to 21? How would we get from 5 to 35, 8 to 56, and 10 to 70? Well, we notice that to get from all of these, I'm not really adding the same number over and over again. I'm not adding 18 or adding 30 or adding 60. Instead, I notice that every single x value is being multiplied by 7. So to get from 10 to 70, I did 10 times 7. 3 times 7 equals 21. So how I could write this equation is I would take my x value and I would multiply it times 5 to get y. Another way we could write this is y is equal to 5x. So that would be my equation. This one again is still fine as well. But I'm noticing that I can put in any value for x, and if I multiply it by 5, I would know what my value of y would be in this situation. Our second recap question is taking the equation and trying to put it on our graph. Now, real quick, we want to remind ourselves about the x and y axis. Well, we have two different axes. We have the x, and our x value, again, our independent variable, is the horizontal line, or the line that goes left and right. Our y is our dependent variable, and that is our vertical line that goes up and down. So as we have our different values of x and y, again, we're going to figure out different numbers for x, and let's just kind of keep it easy here. How about even, let's match these numbers that I already see here. Oh, let's do it in our blue. 2, 4, 6, and 8. Well, if I know my equation is x plus 3, all I have to do is add 3 to my x each time and that would give me my y value. So in this case, if I had 2 plus 3 would give me 5. 4 plus 3 would give me 7, 9, and 11. So how do I graph these different points? Well, remember we have ordered pairs, which is where I take my x value first and my y value second. And that is where I can put my numbers like 2, 5, 4, 7, and so on and so forth. So how do I graph? I always start at the point 0, 0, which is my origin, and then I'm going to go 2 spaces in the x direction, so 1, 2, and then I'm going to go 5 spaces in the y direction, 1, 2, 3, 4, 5. So I have my point right here at 2, 5. Now I'm going to just plot those other points so that you can see if you were able to find those ones as well. While you're waiting for the answer, see if you can pause the video and try to see if you can be able to do these without my instruction. So I was able to plot those other different points, my 4, 7, 6, 9, and then even the 8, 11, even though I went off of the grid, I could still figure it out by kind of just guessing where that line would be and knowing that it was going to be coming up. Oh, I guess I could have a little bit over more to the right. So the only other one that I didn't put here is our first number, which is 0, 3. And that's because I wanted us to remind that if we have 0 in the x direction, we stay at the origin and we just go up 1, 2, 3. So because we have all of these, they all have something in common. We actually know that this is something called a linear or a line relationship, which means that it's constantly growing at the same rate. So this should be a line, a nice straight line, but Mrs. Condrick's stylist isn't wanting to play along. But that's how we can see and graph that this is constantly, every time I put in an x value, it grows by 3. So as long as you were able to, again, find different points, and you could have different numbers other than 2, 4, 6, 8. If you wanted, you could have 1, 2, 3, 4, 5. You can have any different mixture of numbers as long as they are obviously on our x-axis so that you can graph them. This is a quick little what do you notice and what do you wonder. When I'm looking at Memphis and I'm looking at Bangor, I want to just see what do you notice and what do you wonder about these situations. So this isn't one that actually has a right or wrong answer. It's just more of, as a class, what are we curious about and what do we notice is different, even though they're both on a Saturday between 5 and 6 p.m. What do you notice that is the same or different about these two places, and what do you wonder about? Some things we can notice is that there are 2 different places at 2 different times, but on the same day. We also can notice one is raining and the other one is partly cloudy. We can notice that there are 2 numbers for each. There happens to be a high number and then a lower number. We notice that this place is colder because it is has a 1 degree Fahrenheit versus 37. We also know that there is a positive value for Celsius in Memphis, but there's a negative Celsius for our other place. So these are just some things that we can notice, but again, noticing that there is a Fahrenheit and a Celsius, those are 2 different degrees of temperature. So that gets us kind of, after we noticed and wondered about positive and negative numbers in our example, we just want to remind ourselves about what positive and negative numbers are. We have a number line, and we have 2 different types of number lines. We have a horizontal number line, just like the x-axis, where it goes from left to right. And all of our positive numbers are anything to the right of 0. On a vertical number line, which is just like this over here is vertical, all of the positive numbers are above 0. So we have our positives over here going up and our positives going to the right. Our negative numbers are numbers that are less than 0, and they go to the opposite direction of the positive numbers. What I mean by that is if I'm at 0, as I go one step away, that's -1, -2, -3, -4, so on and so forth. So our negative numbers are to the left. If we are looking at our vertical number line, all negative numbers are less than 0, so they are being shown going downwards. Hey, Mrs. Condrick, what if I put them together? Well, if I put them together and I had another horizontal line with my vertical line, I would notice if I started at 0, all of my positive numbers would go to the right, and all of my negative numbers would go to the left. Wait, Mrs. Condrick, isn't that the coordinate plane? Exactly. That is what the coordinate plane is. It is a combination of two straight lines meeting at the point 0, 0. So we've been dealing a lot with the first quadrant, which is that positive quadrant. But we are going to be dealing with all the others as well as we go through this next few units. Let's look at positive and negatives in a context. The thermometer showed a temperature of 7 degrees Celsius one morning. Later, the temperature increased 4 degrees. We can represent this change in temperature using a number line as shown in the picture. Well, just like we discussed before, if I have 0, all of my numbers going up are positive. So if I started at a temperature of 7 and I increased it 4 degrees, that number is getting bigger by 1, 2, 3, 4 degrees. So now it's going to be at 11. Well, what about if the temperature dropped 2 degrees? So instead of going at an increase of 4, what if it dropped 2 degrees? Well, if we started at 7, it would drop or go down 1, 2 degrees, so it would be at 5 degrees instead. So it would just be showing that we can go up and down the number line even if it's vertical. What if the temperature dropped 10 degrees? Wait, Mrs. Condrick, we were at 7. If it dropped 10, we would be going 1, 2, 3, 4, 5, 6, 7. We'd already be at 0. We still have to go 3 more places. 1, 2, 3. We would be at -3 degrees. Now that's just showing you that even if we have a thermometer, the thermometer probably actually wouldn't show it. So we're going a little bit out of the context of the question, but I just want you realizing that what happens if we do have a big drop in temperature, how could that be showing going down? So let's do a little bit of practice. Here there are 3 situations involving temperature. Represent each by drawing it on a number line and then answer the questions. So take some time right now to make sure on your Desmos you also label these A, B, and C. And you can connect them again with A, B, and C. So at noon, the temperature was 5 degrees Celsius. So if we start up at 0, we know that we can go up 1, 2, 3, 4, 5, and we can start at 5 degrees. By the afternoon, it has risen 6 degrees Celsius. So we're going to go up 1, 2, 3, 4, 5, 6, and that gets us at 11 degrees. For B, the temperature was at 8 degrees Celsius. So if I start at 0, I'm 1, 2, 3, 4, 5, 6, 7, 8. By dawn, it had dropped 12 degrees. So I'm going to go my 8 to get to 0, but I need to go all the way to 12. So I still need to go 1, 2, 3, 4 more in the negative direction. So I would end up going 12 spots total, but that would get me at -4 because I would go 1, 2, 3, 4 in the negative direction. Water freezes at 0 degrees Celsius, but freezing temperature can be lowered by adding salt water. A student discovered that adding a half a cup of salt to a gallon of water lowers its freezing temperature by 7 degrees. What is the freezing temperature of the gallon of water? So in this case, if we see we started at 0 was the original, we're really actually going to be going down because we are lowering. So lower meaning going down 7. So 1, 2, 3, 4, 5, 6, 7. And we would be at -7 degrees because we're going down 7. All right, well, what about elevation instead of the temperature? How about in high and low places? What about something called elevation? Elevation is the distance a object or something is from something we call sea level. So you can see I gave you a little diagram over here that shows sea level and the actual ocean, and everything above sea level is going up. So you can see here we have a few places that are positive elevations and a few that are negative elevations, which means that they would be below the sea level. So let's answer these questions. On the list of cities, which has the second highest elevation? Well, again, the further away it is from 0, the higher it would be. So we need to find something that is a biggest number away from 0 in the positive direction. So as we look, we can see that Denver happens to have the biggest value, so that is the highest elevation. But the number that's smaller than 5,280, but is still bigger than everything else, happens to be Bethel, Indiana. How would you describe the elevation of Coachella, California in relation to sea level? So again, if sea level is at 0, Coachella is not just 22 feet away, but a -22. So that means it would be 22 below sea level. Again, that negative represents the below sea level or below 0. How would you describe the elevation of Death Valley in relation to sea level? Well, Death Valley is even further away from 0. Again, if I have 0 right here, and I had Coachella was at -22, Death Valley would be even further away from 0, all the way at -282. So it would be 282 below sea level. Sorry for my ugly handwriting, but I think you guys are figuring out. Again, that's supposed to be 282 below sea level. That negative is showing it's below. For D, if you're standing on the beach right next to the ocean, what is your elevation? Well, at that point, we know that if that is at the level of the sea, it would be at an elevation of 0. So you wouldn't be above or below the level of the sea. You would be right at the level of the sea, which is 0. And how would you describe the elevation of Miami, Florida? Well, since Miami is at an elevation of 0, Miami is at what we call the level of the sea, or sea level. So, a city has a higher elevation than Coachella, California. Select all the numbers that could represent that city. Draw an image of a vertical number line to explain your reasoning. So, before you find this out, go ahead and pause the video so that you can see if you can find all of those correct numbers. So when drawing a vertical number line, I can again have my 0 represent sea level. I know that Coachella is at the negative 22, so I can be able to have that be going down from sea level 22 spaces. I want everything that has a higher elevation than Coachella, so I want anything that is above. So I want any number that is above that 22. Well, I know that 0 would be one of those numbers. I know 4 would be one of those numbers because those are both above where the 0 would be. But now the question is there any numbers that are negative that are between negative 22 and 0? Well, just because I know it's 22 feet away from 0 going down, I still have negative 8 that it passes and negative 11 that it passes as well. So negative 11, 4, negative 8, and 0 are all the same above Coachella. Negative 35 is if I started at 0 and I went 35 down, so negative 35 is further away from sea level than Coachella. All right, so this one's gonna take a little bit of time, but I want you to really just take your time to see if you can be able to map out these different elevations. So we happen to have here 1, 2, 3, 4, 5, 6, 7, 8 different elevations of different trenches and different mountain. So mountains are those big, obviously, formations of rock that go up into the sky, like Mount Shasta, but we're looking at some of the biggest ones in the world. And there are also some trenches, which are formations of big gaps or holes in the earth, the opposite of a mountain. So looking at these, we can notice that we have some that are positive elevations and some that are negative elevations. So we can know that these right here are the mountains and these are the trenches. So what I want you to do is to take your different values, and I see that there's 8,000, 5,000, 6,000, 5,600. And I want you to take a different color, if you can, to try to put each of these elevations on this very nice and tiny vertical number line. So I can do the first one with you. So if I have C, I want to put C at around 8,800. Well, each of these, as you can see, 4 is equal to 4,000 meters. So this one I can put roughly around 8.8 on the number line. So if I start at 0, I can go to 8, and it's a little bit above 8, so that's where I could put C. For H, I'm going to put this around 5.8. So I would be going start at 0, and I would be going above the 4, close to the 6, and that would be H. Let me do a trench for you just so that you can see an example of that too. How about the Tonga Trench? For D, I know this is going to be around negative 10.8 or close to negative 11. So if I start at 0, I'm actually going to go down, and as I'm going down, I can see I'm going past 2, 4, 6, 8, 10. So right after the 10, right kind of by the 11, that's where I want to be able to put my letter D. So I want you to take the time to see if you can find the other ones, and then I will give you the answer key in a few seconds. So there you go. You can kind of see my color coding there, but if we were to put them all in order from going from the top to the bottom of the number line, we would have C, then we would have C, then E, then H, A, G, B, D, then F. Now we can answer some of the questions about that, and you can always reference back to your last slide, slide 10, if you need. So which point in the ocean is lowest in the world? What is the elevation of, again, the lowest part of the world? So we talked about how the Mariana Trench was the furthest away from zero, and that's because it was negative 11,000 feet away from sea level. So for this case, it would be F, the Mariana Trench. For B, the mountain which is tallest in the world was the one that was the furthest from zero in the positive direction, and in that case, that was Everest. For C, if you plot the elevations of the mountain and the trenches on a vertical number line, what does 0 represent? 0 again represents that sea level, or being right at where the ocean is. So not a rock above or a depth of the sea, it would be right at the level of the sea. Which is furthest from sea level, the deepest point in the ocean or the tallest mountain in the world? And to explain. Well, since we know, and again, I guess my numbers weren't coming through here, but for A, the lowest part was the trench. And for my highest point, that was Everest. And if we kind of drew a picture of that, we could be able to see that Everest again was around 8,000. Then we have sea level, and then we would have the trench at negative 11. So a negative 11,000. So since I'm going from 0 to 8,000, that's 8,000 away from sea level. Well, the trench is negative 11,000 away from sea level, so that actually happens to be further from sea level, so the trench is the furthest from sea level. It doesn't matter if it's positive or it's negative, it's just a further distance than Everest is. So again, Everest was the mountain, the trench was for A, for C, that was sea level, and for D, the trench, the deepest point in the ocean, was the farthest from sea level. All right, you guys, for your cool down, I want you to pick which of these statements you agree with and to be able to explain your reasoning. So pick A, B, or C, and then a box is going to come up that says explain. I'm actually not going to give you the answer to this. This is the way for me as your teacher to be able to see what did you really understand about today's lesson and how are you able to explain it to me. Here's a lesson summary if you got confused or if you just wanted to have a recap before doing your homework. This is what we were talking about today, about positive and negative numbers, especially in a situation. We have an example here of a temperature reading, and again, there's the 0, and then we also have here for elevation, sea level being at 0. Last but not least, just your reflection for today is where are you at after this video? But notice this, it's a coordinate plane, you guys. All the positive numbers making sense and being interesting, those are both positive types of emotions, which is why that is showing that coordinate. Being confused or uninterested, those are both negative kind of emotions. That's why it was showing a negative of going down and to the left. So even if you didn't think you understood coordinate planes, but you understood this, you're on the right track. So great job, you guys. Good luck, and don't forget your homework.